Right, good day to all my wonderful online viewers. Just to remind you, if this is your first time of watching this YouTube channel and you have not subscribed, it won't cost you money. Just press the subscribe button, strike the bell also for notification of other videos. And other videos, when they come on board, you'll be able to see them. Thank you for viewing. Let's continue watching this and its compound. Just watch as we continue to explain this carbon and its compound. It's an SS1 third term topic. Just join me as we continue. Now, carbon and its compound. Next slide. Carbon, being at the center of the second period, shows very little tendency to acquire 4 electrons and become carbon anion, or lose 4 electrons to become cation. Rather, it forms 4 covalent bonds. Invariably, what I'm explaining here is that if you draw carbon, the atomic number is 6. K shell has 2 electrons. The L shell has 4 electrons. So carbon is a tetravalent element. It has 4 electrons. It cannot give the 4 electrons. If it gives, that is when it becomes positive. If it accepts, that's when it becomes negative. When it accepts, it becomes negative. And negatively charged ions are called anion, just as you can see here. Positively charged ions are called cation, just as you can also see there. So carbon does not give, neither does it really accept, because it has 4 valence electrons in the atmosphere. So what it does is that it goes on into covalent bonding. Carbon exhibits in free and combined state. It is odorless, tasteless, with high melting point of about 3,500 and insoluble in common solvent like water, like petrol. You can see that. It is capable of forming single bond with itself, with other elements. It's also capable of forming multiple bonds. Ability of carbon to combine with itself is called catenation. While Jam Neko can ask you this in form of question. Catenation is the ability of carbon to bound with itself in forming a chain. This is responsible for numerous compounds. Now, allotropy. What's the definition of allotropy? Allotropy is a phenomenon whereby an element exhibits in 2 or more various forms in the same physical state. 2 or more various forms in the same physical state. Please, you can take note of that. Allotropes of carbon. Carbon exhibits allotropy, and the allotropes, 2 major, are diamond and graphite, are the 2 allotropic form of crystalline carbon. So obviously carbon can be divided into amorphous and crystalline. So the crystalline carbon has 2 allotropes, which are graphite and diamond. The non-crystalline carbon is otherwise called amorphous carbon, and these are, you can see, number 1 is coal, number 2 is coke, number 3 is charcoal, number 4 is sugar charcoal, number 5 is lamp black, and number 6 is carbon black. So as students now, few questions you can ask yourself will be, what are the allotropes of carbon? The crystalline allotropes, the amorphous or non-crystalline allotropes. What are the examples of non-crystalline allotropes? Answer these questions and get sure that you understand them. If you don't still understand them, you can still watch this YouTube video
Continue
again.
with this.
So let's continue.
Don't be tired of washing. Keep washing until you are able to understand all. My online students, we are moving into some other aspects of carbon and its compound. Now just stay on, watch from beginning to the end, all the YouTube videos under this carbon and its compound. Ensure you watch them and ask me questions after you are done with the washing. Now let us see allotropes of carbon. What did I say? Allotropes of carbon. Diamonds are the purest form of naturally occurring carbon. Diamonds are the purest forms of all the naturally occurring carbon. It is the hardest substance known. It has a high melting point. Other properties are properties of diamond. It is very dense and resistant to high temperature. It is resistant to chemical attack. It has a non-conductor. It's a non-conductor of electricity because there are no free valence electrons in its crystal. Take note of that. It does not conduct electricity because there is no free valence electron in the crystal. Now the next one, it is octahedral in shape. Carbon atoms are very closely packed by covalent bonds. So if you are asked what type of bond exists in this diamond, it is a covalent bond. Move on now. Now look at this. Shape of diamond. What's the shape? What can you see? This is the shape of octahedra. So diamond is octahedra in shape. Uses of diamond now. Diamond is dense and hard. They are using drilling. So diamond can be used to drill holes, most especially in the extraction of sulfur. It is used in drilling holes. They are also used in cutting glasses and metals because of their hardness. They are also used based on the property of abrasive. Even carpenters use it as abrasive to smoothen the surface of wood. They are used as jewelries. Diamond can be used as jewelries, showing the sparkling brilliance because it has high refractive index. So if you are listing the uses of diamond, if you say diamonds are hard, you need to give the reason. You say they are used as jewelries, you need to give the reason. So as you state the use, you should also give the reason why it is used for that. Let's move on to the next slide now. Graphite. Graphite is soft and flakes. Soft and flakes easily because its layer crystalline structure. They are in layers, just like the comb of honey. Honeycomb now, they are just in layers. It is relatively inert chemically, but can be oxidized under suitable conditions. It's a good conductor of electricity because only 3 valence electrons are used for bonding and 1 electron from each carbon atom is mobile. That's why it can conduct electricity. Now uses of graphite, as you understood the uses of diamond, the same you should understand the uses of graphite. It is used as dry lubricant. Unlike oil, it is non-volatile. It does not disappear easily and not sticky. It is used as electrode in electroplating and dry cells. It is also used to line crucibles, used in making high-grade steel. It is used to make writing cord. It is used as black pigment in paint. Amorphous carbon. These are forms of carbon which have no definite crystalline structure or shape. Examples of these include wood charcoal. Now, what are the uses of wood charcoal? This is obtained by heating wood in the absence or in the presence of limited air. It is used as fuel in gas mask because of its ability to absorb smoke and poisonous gases. It contains impurities such as sulfur. It is also used to purify or in purifying noble gases and receiving industrial solvents. So please go through this again. Go through the uses of diamond, the uses of graphite, and make sure you understand them very well. Thanks one more time for watching and for learning and for growing.